In this video, I'm going to talk about catalysts. And catalysts are simply something that speeds up a reaction without being used up. And the way catalysts work is that they simply lower the activation barrier, the activation energy. And we talked about if you have a low activation energy, you're more likely to go over it, therefore speeding up your reaction. And a lot of times what happens is that your catalyst will react with a general one of the first elementary steps, but then it will be remade in a later step because a catalyst has to not be consumed to be a catalyst, right? And so let's take a look at this where we have oxygen, we have ozone oxygen plus atomic oxygen making 2 moles of O2 gas. Normally this has a high transition state, but if you use a catalyst, you see the transition state, the activation energy is a lot lower, which ultimately speeds up your reaction. Something to note though, using a catalyst, you do not change the energy of your reactants and you do not change the energy of your products. Your starting and final energy is the same. Therefore, delta H of a reaction does not change with a catalyst. And we have 2 different types of catalysts, heterogeneous and homogeneous. So heterogeneous simply means that you're in the same phase as the reactant particles, and homogeneous means you're in a different phase than the reaction particles, right? So for heterogeneous, they more or less, you have one reactant molecule, and you hold it in your proper orientation, and then the reaction occurs. Now homogeneous, you actually react with the reactant to make a more stable complex that lowers the activation energy. So heterogeneous just holds on to something. Homogeneous actually reacts with something. And that's it for this video. I'll see you in the next chapter.